So concentration is used to describe solutions. And when you have a solution, remember, is a homogeneous mixture. And there's a solute dissolved in the solution. And so there's a solvent that does the dissolving. And so the amount of solute is what is described by concentration. Okay, so there's different ways we can express concentration. We can express concentration using percent or parts per million and parts per billion. And those are, we have used parts per million and parts per billion for water pollutants and also for air pollutants. So that's for very dilute or not very much solute that's dissolved in air. We don't want too much pollutant in our air or in our water. But the most common in lab that we find is called molarity. So molarity is an uppercase M, and this is a calculation that involves the moles of the solute divided by the liters of the solution. And so it's used for solutions that we'll be using in lab in reactions. So for instance, if you see a bracket, these brackets mean the concentration of whatever's in the brackets. So for instance, if you see this bracket, which is brackets with NaCl, that's telling you that the concentration of your NaCl solution is the number, and that number is in molarity, which is that uppercase unit, uppercase M unit. So for instance, if you have 1.0 molarity solution, you could put NaCl in brackets equals 1.0 and uppercase M, which means molarity. Now this molarity is also an equation. So molarity is a unit and an equation. So it's an equation that you can use to calculate, and it's also its own unit, that uppercase M. Okay, so this 1.0 molarity means you have 1.0 moles, and moles are a way to calculate, in chemistry. And we have moles of NaCl over L, uppercase L, which is liters of solution. Okay, so we haven't gotten into moles, and we won't need to except for calculations of concentration. So this is the solution where you have sodium chloride. We know that sodium chloride, NaCl, is aqueous. It is dissolved in water easily. So you don't actually have NaCl. You have Na plus and Cl minus ions, where both of those are aqueous and dissolved in solution. So when you have a solution that is 1.0 molarity NaCl, it actually means you don't have the NaCl. You have the sodium ions and you have the chloride ions, and each of those have a concentration of the original 1.0 molarity. So you have the individual ions when you have an aqueous solution, okay, and the original concentration of the solution applies to each of the ions, and this is when this is a 1-to-1 ratio.